Good evening, everyone. Welcome to this lecture video. In this lecture video, we have the process scheduling and synchronization. In this lecture video, having the going to discuss about the semaphores. What is semaphores? How the process helping for process scheduling and synchronization. Semaphore is an object. It consists of counter and waiting list for a process and two methods. Method signal, method wait. It have the counter and waiting list. The counter having the which process counters, an example functions, signals and wait. So semaphore is generally we are considered as an object in the operating system. Semaphores have semaphore method having the wait. First one is the wait. For example, here void wait of semaphore of s dot count. If s count is less than equal to 0, add the caller to the waiting list block. So after decreasing the counter by 1, if the counter value becomes negative, then add the caller to the waiting list and then block itself. So this is a semaphore method. Wait for the next caller or whoever waiting in the waiting list have to follow the above conditions. The semaphore method signal. Wait and signal is the two method of semaphores. In the method we having the void signal s countless. If count less than equal to 0, remove process p from the waiting list and resume p. And we can close the loop. So after increasing the counter by 1, if the new counter value is not positive, then remove the process p from the waiting list. Resume the process of execution p and return 3 and return. So improvement note having the count less than 0 is the number of waiting process. This is because process are added to removed from the waiting list only if the counter value is less than 0 or respective less than equal to 0. So important note 1 by 4 we having the methods here. Then sorry for the things we having the excuse me. In this lecture video we discussing about the semaphores. In the semaphores we having the counter value. In this case two process continue. Then most important note 4 by 4 is a wait and signal must be executed automatically, so otherwise race conditions may occur. The use execution sequence to show race condition if wait or signals is not execute automatically. So wait and signal can have the process here. So wait and signal must be executed automatically. Is uninterrupted unit. So otherwise race condition may occur. So then homework using the execution sequence to raise conditions if wait and signal is not executed automatically. Then three typical use of semaphores are mutual exclusion, countdown lock, and notifications. Mutual exclusion locks. Keep in mind the semaphores have a counter and indicate an event has occurred. So three types of semaphores we are using. So first one mutual exclusion. We are having the how s equal to 1 and what are the conditions using here. Then count s equal to 3. If after 3 process pass wait, this section is locked until the process signal. So process 1 and process 2 while do something. If wait at most 3 process can be here. Signal do something. So this is a loop. We can have the counter down counter here. Then use case of 3 we have the wait and signal will be a s1 wait will be notified by the signal, s1 notify will be by the wait. So process 1 you having the things by using these notifications. So lock example by dining philosophy. Five philosophers are in a thinking or eating cycle. So when a philosopher gets hungry, he sits down, picks up two nearest chopsticks and eats. The philosopher can eat only if he has both chopsticks. After eating, he puts down the both chopsticks and thinks. So this cycle continues. Dining philosopher ideas. Chopsticks are sad items by two philosophers and must be protected. Each chopstick has a semaphore with the initial value 1. So this can be before picks up things and the other to release it. So dining philosopher code we having the things we having the wait and signal. So wait for left chop and other wait for right chop and release for the right chop. So does this solution work? So dining philosopher code we are using this formula. So dining philosopher have occurs some deadlock also. We already seen how deadlock occurring. In this dining philosopher, all five philosophers sit down and pick up their left up at the same time. This program has a circular weighting and deadlocks, and this can be discussed in the next video. Thanks for watching these semaphores. Hope we all understood the semaphores in the operating system, how the dining philosophers and other examples using the semaphores with different methods using the semaphores. Thanks for watching this video. Thank you.